So I thought I would break up the LPB1 series with a look at hard clipping diodes and how they are utilised in guitar pedal designs. Hard clipping diodes can be found in numerous pedal classics such as the Klon Centaur, MXR Distortion Plus, Boss DS1 and my personal favourite, the Proco Rat. So what are diodes? Diodes are semiconductor devices. This means in some conditions they will conduct and permit electron flow, and in others they won't. Diodes permit current flow in one direction within the circuit. This is when the diode is forward biased. Diodes will be labelled with an anode and a cathode, as shown here. They are most commonly constructed with germanium or silicone. The diode is constructed with a single PN junction, where one piece of P-type doped silicon and one piece of N-type doped silicon are wedged together. Where these two materials meet, there is something known as the depletion region. At this depletion region, some of the spare electrons from the N-type doping diffuse over the region and into the holes at the beginning of the P-type doped material. This gathering of electrons creates a barrier, and as electrons carry a negative charge, this will create a negative region that will repel other electrons from flowing. To overcome this depletion region and motivate electron flow, we need to apply a voltage to the P-type doped section of the diode. The voltage required for a silicon diode is 0.6 to 0.7 volts. Once this voltage value is met, current flow will begin, and this is known as forward bias in the diode. When this voltage value isn't met, current flow won't be permitted within the diode. This is known as reverse biased. That's an insight into diodes and their construction. Now to take a look at these diodes within a circuit. Now to create distortion or overdrive, we need to round off the waveform, giving an impression of a squared wave. The first step is to add large amounts of amplification to the incoming signal. This can be achieved with an op-amp or transistor. The maximum amplification in the MXR Distortion Plus is around 213. With the Proco Rat having a maximum rating at an incredible 2305. So as we can see, huge amounts of amplification are required. This then amplified signal goes towards the diodes. So for a symmetrical hard clipping diode circuit, we utilise two diodes shunt to ground. There is one diode with the cathode facing up and the other with the anode facing up. As we have noted, these diodes require voltage to begin conducting. Due to this now large amplified signal, achieving this voltage is not an issue. At 0.6 to 0.7 volts, on the positive swing of the waveform, the diode with the anode facing up will begin conducting, sending all the signal above this rating to ground. This in a way acts as a limiter, with only values under this forward bias voltage of the signal being left. The same happens for the negative swing of the waveform with the alternative diode. From this graphical representation, we have the blue line representing the amplified signal heading towards the diodes, and the green line representing the signal after the diodes. With this amplified signal being limited at the values mentioned, you can see the waveform now has a closer impression to the square wave we are trying to achieve. If you utilise more diodes in one of the paths, this would lead to asymmetrical clipping. If you utilise two diodes, this will increase the forward bias required. If we use two diodes in the path affecting the negative waveform, this will double the forward bias to 1.2 to 1.4 volts. Sending only the signal levels above this value to ground, we will be left with more voltage values on this portion of the waveform. With this graph again, you can see the negative portions are larger in value, leading to this asymmetry. If you utilise germanium diodes, they have a reduced forward bias voltage, usually around 0.2 to 0.3 volts. This leads to a further compressed sound with reduced headroom. Another often notated comparison between the germanium and silicone diodes is the knee they turn on with. Germanium diodes turn on smoother, lending itself to the smoother vintage tone people often describe germanium diodes as possessing. Silicone diodes turn on much harsher, leading to a more aggressive feel in comparison to their germanium counterparts. Trying out different diodes when designing a hard clipping device is part of the process in achieving the fingerprint of a device's sound. alternating between germanium, silicone, symmetrical and asymmetrical, and different model numbers of each diode are areas to experiment with. In both the Mind Flare and the Gatekeeper pedals I release over at Buzztone Audio Effects, I utilise switches alternating between different pairs of diodes, giving the user some parameters to play with and tailor the characteristics of the device. So that's it for this video on hard clipping diodes. Feel free to fill in anything I may have missed or give some feedback. See you next time.